Alright, I want to graph this logarithmic function. In order to do that, what I first want to do is I want to graph the parent graph of this. What I mean by parent graph is I want to graph log base 4x, or log x base 4. Because I don't want to deal with this 1 and 2 right now, so I'm basically, since this is base 4, I'm going to graph a simpler graph, and then from there, I'm going to translate it. Here's what I mean. Hopefully you realize that this would be a shifting of negative 1, 2. If you think of it back to vertex form, the vertex would be negative 1, 2. So that gives you a shift of what's going to happen to our parent graph. Negative 1, 2 means, if you think about that, negative 1 means you're going to go left 2, left meaning this way, sorry, 1. Negative 1 right here means you're going to go left 1, and the 2 means you're going to go up 2. So you'll see in a second what I mean by that. But basically, we're going to ignore the 1 and the 2, and we're going to shift it later to get our answer. So I'm going to focus on log base 4x. In order to do that, what I do is I'm going to use this function. I got to think of values I could plug into this that are really easy to calculate without a calculator. So what I'm going to start off with is 1/4. Now that probably is the hardest one to recognize, so let's come back to that. I'm going to start with 1. Anytime you take a log of any base, 1, your answer is 0. So that one hopefully would be pretty easy. I always want to do 1. 1 is always the best one because it's 0. Then another one is if the base is 4, well, if you take and put 4 in, you get log 4 base 4, that's 1. So anytime whatever the base is, that's also the number you want to plug in. So that's 0, that's 1. And then where I got 1/4 is I took the reciprocal of this. Whatever the base is, you take the reciprocal. That's where 1/4 came up. Otherwise, it helps to see these first before you go back to where 1/4 came from. Anyways, when you plug 1/4 in, you can separate that. You can expand it. Divides or minuses. So 1 divided by 4 would be 1 minus 4 logs base 4. So you take these two logs base 4, subtract them, and as you know, this is 0, as you can tell right here. This is 1, as you can tell right there. 0 minus 1 is negative 1. So you see how I have really nice results here? And if I plot these values, 1/4 negative 1, see right there? Over 4 down negative 1, 1 0, over 1 up 0, and 4 1 over 4 up 1. See the red is this red graph. Now that's not your answer, but as we talked about earlier, this negative 1 2, remember it's always opposite what's in the parentheses? That's where negative 1 came from, by the way. This tells you the shifting, the translation, which you did in geometry. So what I'm going to do is I'm going to take every coordinate and I'm going to go left 1 and up 2. So this coordinate, I'm going to go left 1, up 2. I'm going to take this coordinate, go left 1, up 2. This coordinate, go left 1, up 2. And then I have my green graph, which is the same graph as the red, just shifted. Now, so this green is your answer. Now, what is this little dotted green line? It's called an asymptote. These logarithmic functions go up along that dotted line but never touch it. They get really, really close but never touch. So this red goes up along this red dotted line, like that. So that's where this little asymptote comes in. So it kind of shows where you're going up against. So we basically drew the red and then moved it over according to this coordinate or these description. Now, one thing interesting is if you choose this wisely, you choose these kind of values, you always choose 1. If you choose the base, and if you choose the reciprocal of the base, it's always going to be negative 1 0 1. So this graph would look very familiar over and over again. And then you just shift it according to negative 1 2. And then that green is your technical answer or your graph of this problem. The red is the graph of this, the parent graph.